Avikal didn't start in a corporate cybersecurity lab. It started in 2024 with a personal obsession and a very simple question. Can you hide an entire secret inside a game of chess? I have spent most of my time playing competitive chess, staring at these 64 squares. But I was also fascinated by steganography, the ancient art of hiding information in plain sight. Normally, when you encrypt a file, you put a massive digital padlock on it. Everyone can see that a vault exists, which immediately makes hackers want to break it. But steganography is different. It's not about putting a stronger lock on the box, it's about making the box disappear entirely. So I started experimenting. In chess, every legal move is essentially a mathematical choice. What if we use those choices to encode digital data? I built early prototypes that tried to shove entire secret files directly into chess notation. Whenever a single game line ran out of room, I built algorithms to branch off into recursive variations, creating a massive expanding tree of alternate chess timelines just to store more data. At first, it felt like magic. I was literally translating raw digital bytes into king, queen, and rook movements. But in software engineering, exciting ideas eventually collide with reality. And as I pushed the system to handle real-world files, I hit a massive mathematical wall. There is only so much data you can force into a chess game before it breaks. If you try to hide a heavy file, like a high-resolution document or a software package, directly inside chess notation, the game becomes millions of moves long. It causes severe data bloat, it exhausts the CPU, and it becomes completely impractical for real-world use. Most people would have looked at that wall and abandoned the project, but I realized the problem wasn't the chessboard. The problem was how I was using it. To build a true digital fortress, I had to stop forcing chess to do all the heavy lifting and completely redesign how a digital archive is built from the ground up. When you hit a mathematical wall, you have to look at the problem from an entirely new angle. I stepped away from the chessboard and started studying how everyday software packages and zip files are built. Most people think a Word document, a .docs file, is just a simple document, but it's actually a zip container. If you open it up, it's a package of hidden folders, formatting rules, and XML data all bundled together. That sparked an epiphany. Instead of trying to force a chess game to carry gigabytes of heavy files, what if Avikal became its own custom, intelligent container? A normal archive just bundles files together. A basic encrypted archive just puts a lock on the folder. To build Avikal, I had to do something radically different. I designed a composed archival security system that splits the entire architecture in half. When you create an archive in Avikal, it divides your information into two distinct layers, a data plane and a control plane. First is the data plane, stored as a custom sealed file called payload.enc. This is where your actual files go. Whether you are storing private legal records, high-resolution images, or entire directories, they are placed into this payload. Here, we don't play games. We use heavy-duty, industry-standard authentication and encryption to compress and seal your files. Because we aren't shoving this bulk data into chess notation anymore, the system remains lightning fast. But if the files are sealed in the payload, where do the keys go? How does the archive know who is allowed inside, when it can be opened, and how to verify the data? That is the control plane. And this is where my original dream of chess steganography found its true purpose. Instead of storing your sensitive access rules and master keys in a standard, easily targeted header, Avikal translates that entire control envelope into a legal, playable game of chess, keychain.pgn. The heavy encrypted files are sealed in the payload, but the blueprint to unlock them, the access keys, the cryptographic signatures, and the release rules are mapped deterministically into a chess variation tree. If anyone else examines your computer, they don't see a master password file. They don't see an exposed cryptographic header. They just see a standard PGN chess match. Chess isn't a gimmick here, and it doesn't replace encryption. It is a structural disguise, a control plane hiding in plain sight on a 64-square board. By separating the heavy files from the chess metadata, we solve the mathematical bottleneck completely. But a brilliant architecture on paper is worthless unless it executes flawlessly in the real world. It was time to build the engine. Welcome to the Avikal desktop engine. Let's look at how this architecture executes in real time. On the right side of our workspace, under the Encryption Settings tab, we give the user 4 distinct cryptographic tiers: unencrypted archive, access password, security key phrase, and quantum protection. Access password enforces strict entropy. The system actively monitors your input against 5 core security criteria in real time. And as you can see, you cannot proceed until your password is mathematically bulletproof. Security key phrase generates our canonical 21-word Devanagari access path, inspired by hardware crypto wallets, but rooted proudly in Sanskrit linguistic entropy. And quantum protection puts our NIST-standardized PQC suite at your fingertips, allowing you to toggle between standard, maximum, or custom cryptographic library configurations. For this demonstration, I'm loading a bundle of personal files and selecting standard password protection. Watch the live indicator as I type. Only when all 5 security checks illuminate green does the system authorize the build. Now let's hit submit. In just seconds, our secure.avk archive is generated. But real security demands absolute transparency. Clicking Detailed Report opens our diagnostic audit engine. Here, we can inspect exactly what happened under the hood across 7 specialized tabs. Summary gives you the core build metadata and versioning. Verification displays the cryptographic signatures, proving the file's absolute integrity and 0 alteration status. Protection maps out your exact encryption cipher suite. Contents locks down signed cryptographic hashes for every file inside the payload. Performance breaks down the encoding latency millisecond by millisecond. ChessPGN reveals the mathematical disguise, showing the mainline moves, recursive variations, total plies, and nesting depth generated to conceal your keys. And technical details, the underlying system architecture and libraries used. You can export this entire audit trail as a JSON or PDF report, while an everyday user can simply create their archive and walk away. This deep audit trail is built for cybersecurity researchers and developers who need to verify every single byte. Now let's flip to the decode page and test our defensive boundaries. I'll upload our newly created personal.avk. To see how the engine handles an unauthorized brute force attempt, let's intentionally enter an incorrect password. Notice what happens when I hit submit. The decryption process begins its cryptographic handshake, and within seconds the authentication fails. The system throws a hard security rejection, 0 tolerance. Now let's enter the correct password and submit. The decryption engine unlocks the payload smoothly. Immediately upon opening, we can access the accuracy report, our post-decryption integrity check confirming that not a single byte or cryptographic signature was altered while in storage. Everything passes. Now here is one of Avikal's most powerful architectural advantages: granular access. What if you have a massive multi-gigabyte archive, but you only need a single file? Instead of forcing you to decrypt and dump the entire payload onto your hard drive, Avikal's Browse Contents feature lets you inspect the internal directory in memory. Watch as I select just 2 specific files from the list and hit extract. The engine decrypts only those 2 items, making them instantly available for preview and download. And of course, when you need the entire container, a single click seamlessly decrypts and extracts everything into your local preview folder. Fast, transparent, and completely under your control. To understand why Avikal goes further than standard encryption, look at the biggest looming threat in cybersecurity today: harvest now, decrypt later. To solve this, I spent 5 intense months building a native post-quantum cryptography architecture on top of OpenSSL 3.5+. We integrated NIST-standardized algorithms using MLKEM for hybrid encryption and MLDSA for dual signatures, ensuring your archives are mathematically hardened against tomorrow's quantum attacks. I noticed almost every high-security seed phrase system in the world is strictly English first. To challenge this, I engineered a native Devanagari key phrase system. Instead of complex random strings, Avikal generates a validated 21-word canonical Hindi phrase with built-in checksum verification, delivering high-entropy cryptography rooted proudly in Indian linguistic heritage. With Time Capsule, which integrates decentralized public randomness networks like DRAN, you can seal a file so its decryption key literally cannot be broadcasted by the network until a precise this future timestamp arrive. And with zero downtime rekey, you can seamlessly rotate your access keys without ever needing to decrypt and re-encrypt your massive underlying payload. What we have engineered is an uncompromised, sovereign, archival fortress, transparently layering ancient chess steganography, Indian language key phrases, decentralized time loss, and post-quantum armor into one unstoppable desktop engine. And because true engineering confidence welcomes global scrutiny, I released RookDuel Avikal, 100% open source. What began in 2024 as a solitary experiment with a chessboard in Kolkata has grown into a sovereign next-generation digital vault, proving that Atmanirbhar systems engineering can redefine global data privacy. I invite you to test the engine and inspect our code. My name is Atharva Senbarai. Thank you for watching, and welcome to RookDuel Avikal.